At Dyson, we design things to work better, to solve a problem. And it can be a painstaking process. We have to consider every aspect of the machine, how it works, how it performs, how it's used. And every step of the way, we test and evaluate to make sure we fully understand the technology that we're developing and to be able to compare ourselves against others.
So, for an upright vacuum cleaner to pick up effectively, it employs two mechanisms. Firstly, there's the brush bar which spins around in the cleaner head, and as the bristles rotate round, they agitate the fibres of the carpet and help release the dirt. And then the second mechanism is suction. So the suction draws that dirt away, puts it through the machine into the cyclone where it's separated from the air. So in this test, we've got the machines mounted up on an AirWatts box, and this allows us to measure the suction at the cleaner head, the bit that's actually doing the work on the carpet. And both machines are running, and you can see the Dyson has twice the suction at the cleaner head than the Vax. Some cleaner heads have fiddly dials or sliders that you have to manually adjust for the different floor types.
Ours we've designed so it automatically adjusts, so it's optimised whether you're cleaning carpets or hard floors. And the way it works is on carpets the sole plate rides up and the bristles penetrate down so they can clean the fibres of the carpet and agitate the fibres. On hard floors, the sole plate drops down, creating a close seal to the hard floor, and that means you get really good pickup on hard floor and in crevices. We've designed the cleaner head so it will work really well on hard floors, carpets and on crevices. So the test is 5 double passes, but pretty much after the second pass, nearly all of the dust in the crevice is gone. In fact, it's even sucked the dust underneath there out from the sides. So now we've got the Vax machine on the rig. Let's see how it performs. So after the first couple of passes, there's still quite a lot of dust left behind. So even after going forwards and backwards 5 times, you can see there's loads of dust that's been left behind and nothing's been removed on either side. So when we designed DC41, we house the motor and the filter down at the bottom in a ball. And what that means is the machine's incredibly manoeuvrable. So when you're trying to go around tables and chairs, with just a flick of a wrist, you can negotiate the bends. So some other machines also claim to be manoeuvrable, but because they don't have a ball, it means they don't steer around corners as well as the Dyson machine. The geometry of this machine means that as I turn the handle, it will steer a little bit, but not enough to get round a bit of furniture. I have to walk right round to go around the corner properly. So when you're cleaning your house, it's not all about vacuuming carpets. You want to clean the stairs, you want to clean around the architraves. And the DC41 has a quick draw wand, which instantaneously comes away, and the suction transfers automatically to the wand. So straight away I can go up the stairs and clean up the stairs. And to put it back, it just slots back into place. Other machines also have a hose that will reach the top of the stairs. But to convert them, you have to unplug it here, wind the hose, take the handle out, do all that before I can start cleaning. So it'll get to the top of the stairs, but again, I have to reassemble it all before I can carry on with vacuuming. It's nowhere near as convenient as the DC41. As well as designing a machine to perform really well, we have to make sure it's really robust and durable. To do that, we do a lot of mechanical testing, actuating and bashing and trying to break every single part of the machine to make sure it can withstand the rigours of 10 years of use in someone's home. So the polycarbonate material we make our bins out of is so tough it's used for riot shields. So it's a bit of a hard test, but it makes a point. Dyson, we design things to work better, to solve a problem. And it can be a painstaking process. We have to consider every aspect of the machine, how it works, how it performs, how it's used. And every step of the way, we test and evaluate to make sure we fully understand the technology that we're developing and to be able to compare ourselves against others.
So for an upright vacuum cleaner to pick up effectively, it employs two mechanisms. Firstly, there's the brush bar, which